For this presentation, we will be doing a boxer cross punch. The purpose of a boxer cross punch is to be used as a main or counter attack to disorient an opponent during a physical fight. To fully understand this motion, we break it up into 3 phases: preparation, execution, and follow-through. The preparation phase begins with the individual's arms elevated with their fists protecting their face and one leg set further from the opponent. This position uses the class 3 lever of their elbow. The internal force of the biceps brachii lifts the weight of the radius, ulna, and entire hands, causing bending at the fulcrum joint. The wrist flexors are used to support the individual's wrists and keep their hands in a stable fist position for the punch. The shoulder muscles, such as the latissimus dorsi, teres major, and pectoralis major, as well as the rotator cuff muscles, supraspinatus, infraspinatus, teres minor, and subscapularis, are used to adduct the arms and keep them close to the body, as well as rotate the arm backwards. The rhomboids major and minor, as well as the trapezius, are used to downwardly rotate the scapula and lower the shoulders for the winding up motion, as well as support the neck. The core muscles, such as the rectus abdominis, obliques, transverse abdominis, and erector spinae, are used for stability of the spine while standing. The external force of gravity keeps the individual's feet on the ground, causing an equal and opposite reaction with the floor where no movement occurs. The gluteus maximus and hip flexors are used to stabilize the pelvis in a standing position. The quadriceps are used mainly to support the leading leg, whereas the hamstrings support both the leading and rear leg. The gastrocnemius and soleus stabilize the ankles and feet while in a dorsiflex standing position. The execution phase begins when the individual steps forward and extends their moving arm so their fist makes contact with the opponent's face. This motion incorporates the shoulder and elbow, which are both class 3 levers. For the shoulder movement, the internal force of the pectoralis major, deltoid muscles, latissimus dorsi, teres major, and the rotator cuff muscles are used to elevate the weight of the entire arm at the fulcrum, flexing the shoulder joint. For the elbow joint movement, the internal force of the biceps brachii and triceps brachii lowers the weight of the lower arm and hand at the fulcrum, extending the elbow joint. This torso rotation is considered a third-class lever. This is due to the force of the spinal and core muscles stabilizing the spine against the increasing weight of the upper body rotating for the punch, creating rotation on the thoracic and lumbar spinal vertebrae. The hips rotate slightly with the torso to allow for more movement during the punch. The hip rotation is characterized as a third-class lever, with the force of the pelvic muscles working against the weight of the upper body at the fulcrum of the hip joint. The gluteus medius, minimus, maximus, hip flexors, quadriceps, adductors, and hamstrings are engaged so the individual steps forward and are then used to support the leg when it hits the ground. When their leg hits the ground, the leg begins to extend to move the whole body forward, engaging the quadriceps to extend the knee. The rear leg flexes at the knee joint when the individual steps forward. This engages the hamstrings, hip flexors, and adductors to support the knee while flexing. The knee joint is classified as a class 3 lever, with the force of the leg muscles supporting the weight of the body at the fulcrum. The rear foot plantar flexes, pushing itself off of the ground to provide more momentum for the punch. The gastrocnemius and soleus is engaged in the individual's feet to stabilize the ankles and dorsiflex and plantarflex the feet. The ankle joint is classified as a class 2 lever, where the force of the calf muscles elevates the weight of the foot at the fulcrum or the metatarsal phalangeal joint. The action of the rear foot pushing their calcaneus off of the ground has an equal and opposite reaction where the ground pushes up on their foot, causing the calcaneus to leave the ground. When the individual steps forward, their foot pushes against the ground. The force of the foot pushing against the ground causes an equal and opposite reaction with the floor, causing the foot to leave the ground. When the foot lands on the ground, there is an equal and opposite reaction of the ground pushing up on the foot. The same goes for the rear foot as it briefly leaves the ground during the stepping motion. These internal forces of the individual muscles creates an imbalance of forces which creates motion. The motion of the arm rotating forward and the torso rotation occurs on the transverse plane and the longitudinal axis. The path itself of the individual's fist moving to the opponent's face as well as the stepping motion is classified as linear motion. However, there is rotation of the individual's torso along the longitudinal axis, which is rotational motion. This would consider the entire movement as general motion since there is a combination of both occurring. When the individual's fist comes into contact with the opponent's face, the wrist flexors are used to stabilize the wrist and keep the hand in a closed fist to decrease the risk of injury from the force. The external and centric force of the individual's fist connecting with the opponent's face causes an equal and opposite reaction where the opponent's head begins to move backwards with the force of the punch. The follow-through phase is when the individual's fist forces the opponent's face to move backwards with their fist. This phase mostly consists of continual rotation of the torso and upper body, which happens along the transverse plane and longitudinal axis. The trapezius and levator scapula are used to lift the scapula and support the neck to allow more rotation for a stronger punch. The latissimus dorsi, deltoids, teres major, pectoralis major, and rotator cuff muscles work together to medially rotate the arm and flex and stabilize the shoulder joint. The triceps brachii and biceps brachii are also used to stabilize and extend the elbow joint for a stronger punch. The pressure from the opponent's face engages the wrist flexor muscles to support and stabilize the wrist and keep the hand in a closed fist position. The continual external force forces the opponent's head backward, allowing the fighter to move their fist further than the opponent's head originally was. The applied force of the puncher's fist causes an acceleration in the opponent's face similar to that of the force of the fist. This changes the velocity of the opponent's face so that it moves back in the direction and speed of the fighter's fist. Eventually, the person's arm stops moving due to the internal force of the body's muscles and the external force of the friction created by the contact with the opponent's face. This phase of the cross punch is classified as angular motion since there is mainly a rotation of the trunk occurring. The core muscles are used to stabilize the spine and allow further trunk rotation to occur. The glutes, quadriceps, hamstrings, and adductors continue to support the hips, upper legs, and knees in their slightly bent position during the continuing rotation. The gastrocnemius and soleus stabilizes the leading leg's ankle in its dorsiflex position with the extra body weight from the rotational motion. The gastrocnemius and soleus is used by the rear leg's foot in its plantar flex position for supporting the ankle and lifting more of the foot off of the ground. Now we will move on to the biomechanical principles.
Principle 1. Stability. The greater the mass, the lower the center of mass to the base of support, the larger the base of support, and the closer the center of mass is positioned to the base of support, the more stability increases. This is used in the cross punch because the core stabilizes the spine by the abdominal muscles creating a rigid cylinder around the spine. When the spine is stabilized, it stabilizes the whole body. The center of mass is an inch inferior to the navel and it's halfway between the lower back and stomach for a woman. But for a man, it's slightly above the navel, but can vary for each depending on the posture and body weight of the individual. Principle 2. The production of maximum force. The production of maximum force requires the use of all possible joint movements that contribute to the task's objective. Biomechanical studies on Olympic athletes have shown that the most force has been generated while performing a cross punch. The production of maximum force requires the use of all possible joint movements that contribute to the movement. In this case, third-class levers such as the knee joint and hip joint are used for maximum force. The spine movement used is considered a first-class lever and the fulcrum is the vertebral disc. The increased movement in the spinal lever produces the maximum force needed for a stronger punch. Principle 3. Sequencing of joint rotation. The production of maximum velocity requires the use of joints in order from largest to smallest. The sequencing of joint rotation is the order that the joints rotate during a movement. The cross punch uses a sequential rotation of body parts to impact the opponent with the most power possible. First, the feet and ankles move, then the knees, then the hips and pelvis, then the spine, then the shoulders, then the elbows. Then after, the wrists and hands. The cross punch is a full body effort. Principle 5. The direction in which movement usually occurs. And movement usually occurs in the direction opposite that of the applied force. The shoulders and elbows medially rotate when the punch is thrown and the elbow extends when the arm straightens. The wrist also rotates medially and the hips and torso rotate in the direction of the punch. Principle 6. The effect of a force acting at some distance from an axis. Angular motion is produced by the application of a force acting at some distance from an axis, that is, by torque. It is helpful to know how torque is used to create maximum power and speed in the punch. The greater the distance from the axis of rotation, the greater the torque produced. When the arm is fully extended away from the axis of the body, it generates the most torque possible and makes the punch as powerful as it can be.